Welcome to Statistics for Surveys, Session 2 Tables, Optional Segment 6-5, Formula for Frequency Density. The objective for this segment is to understand how to create and read a formula for frequency density. It's useful if you already understand what frequency densities are, so have a look at Session 2 Segment 3 and that you're familiar with using the summation sign which was discussed in Session 2 Segment 6.1. We'll break it down from text to math formula again. Frequency density is absolute frequency divided by the bin size. So if we take the frequency density and abbreviate that to FD, the is we abbreviate to the equal sign, absolute frequency abbreviate to F, divided by the division sign, and the bin size by W. And we actually compress all of this, then we get the simplistic formula FD equals F over W, which if you would write it down slightly in more math as a real fraction, looks like this up here. Now, there was also a possibility to actually use the indexes. So if we say frequency density of bin I, then it will be FDI is of course still the equal sign. Absolute frequency of bin I will become Fi, divided by remains divided by, and the bin size of bin I will become Wi. Compressed again, and writing it down like a proper formula will give this somewhat perhaps scary looking formula. Note that if you want to reverse engineer this, of course, you can also watch this video backwards, and then you see how you can actually read a formula like this. Because in the end, you then actually go back to writing it out like this, and then actually translating simply what each of the letters actually mean. We also had relative frequency densities, which is the frequency density divided by the total of the absolute frequencies. So relative frequency density, if we abbreviate that to RFD, remains the equal sign, frequency density to FD, divided by the division sign, and the total of the absolute frequencies to simply n. We compress this and we get our nice formula for relative frequency densities. Of course, you can also add the indexes again, so simply being slightly more specific that you want the relative frequency density of the first bin, and that would then be, for example, that I is 1 here as well, the frequency density of the first bin divided by n. For completion's sake, we also discussed in an optional segment the use of standard bin sizes. So we also can create a formula for that if you're interested, which was the frequency density is then the absolute frequency divided by the number of standard bins, so that's a slight difference, and the number of standard bins itself is the bin size divided by the standard bin size chosen. So if we combine these two sentences, we get the quite long but correct formula. Frequency density is the absolute frequency divided by the result of the bin size divided by the standard bin size chosen. So that's a lot of text, and we're going to abbreviate that a lot into a very small formula. Again, we'll abbreviate frequency density with FD is with the equal sign, the absolute frequency with F divided by with the division sign, and the result of means that we'll have to do everything that comes after that. So in math notation, we can use parentheses for that. The bin size is the W divided by the division sign, and we need a new symbol for the standard bin size chosen, so let's use B for that. If we compress all of that, we now get a lot shorter notation for this. And if we write it down in a slightly more math format, it might look like this. Or if you like to use the indexes, it can even look scary like this.